Okay, this will be a short video on processor speed. You probably, to do the quiz, you're going to have to look back at the last video. But let's look at processor speed. People have an idea that a faster, higher speed processor means a higher clock frequency. That's not always the case. Let's look. So, M clock is the master clock. And that's the frequency of the master clock. Most instruction phases require a clock cycle. No clock, no instruction execution. So if your clock is not going, then you're not doing anything, not computing anything. CPI is the cycles per instruction. It's an average number of clock cycles per complete instruction. MIPS means millions of instructions per second, and it characterizes the processor's performance. You know, you've heard of how many MIPS your processor is. The more it is, the better. And so MIPS is a performance index. M clock is not quite that, or CPI gives you a little bit of an idea. So does M clock, but really the idea is MIPS is the bottom line. So MIPS is equal to M clock divided by CPI. So that would give you, the units on M clock are cycles per second, and CPI is instructions per cycle. And so cycles per instruction, I'm sorry. M clock is cycles per second, and then cycles per instruction, then you get instructions per second. And if M clock is in millions of megahertz, so it's megahertz divided by cycles per instruction. So let's look at that. So faster clock speed does not necessarily mean faster computer. For example, if we had an M clock of 2 megahertz, cycles per instruction of 5, the MIPS is 0.4. So if we had an M clock of 1 megahertz, the cycles per instruction of 2, the MIPS is 0.5. So that would be better. So here's a quiz for you. You'll probably need to go back and listen to the last video or look over the slides for the last video. But the question is, given a 1.2 megahertz processor, what value for delay would result in a approximate quarter-second delay for this little assembly language program here? So maybe this will help you do it. First of all, you're moving delay into R12, and you really need to look at what's using up the cycles here in the most innermost loops, because you only need to get an approximately quarter-second delay. I'll let you think about this. And you might also, look at what is the CPI in this program if you really were energetic here.